This is section 1-2, measuring and constructing segments. So a little bit of a warm-up, some review here. When we have 7 minus negative 3, that becomes 7 plus 3 because it's a negative times a negative there, which is a positive. 7 plus 3 is 10. Okay, same thing here. And what I meant by a negative times a negative is this is really a negative 1 right here. It's, as you read it says negative 1 minus negative. That's a double negative, and so it becomes a positive. Negative 1 plus 13. Those are different signs. We subtract them to get 12. Keep the sign of the bigger number. Okay, these bars here are absolute value bars. So we calculate what's inside them first. Negative 7 minus 1. Well, that same sign add and keep. Or if you think about it, if you're at negative 7 on the number line and you go negative 1 more, you end up at negative 8. But then we have to take the absolute value of negative 8. The absolute value is the distance the number is from 0. And so negative 8 is 8 spaces away from 0, so it comes out as positive 8. Okay, solve each equation. We have variables on both sides in number 4, so we're going to subtract 9x from both sides. I get negative 7x plus 3 equals negative 11. Then to isolate the variable, I subtract 3 from both sides. Negative 7x equals negative 14. To isolate x here, you have to get rid of that multiplication of negative 7, so divide both sides by negative 7, and x is positive 2. And we could check our work by plugging in the 2 into the x's. Okay, same thing again on number 5. We have a variable on both sides. So I'm going to use the inverse operation to move that 4x to the other side, so negative 4x to both sides. 3 minus 4x, so it's going to get us negative 1x equals negative 5. Now we have to get the x isolated, so to get rid of the multiplication, I'm going to divide both sides by negative 1, and so x is positive 5. Again, plug that in and check to make sure. How many real numbers are there between 1/2 and 3/4? Let me show you on a number line. This is 1/2, this is 3/4. It would be all of the numbers, in between here. As a compound inequality, this is bothering me. It really should be open circles here. Let me draw that in. Okay, as a compound inequality between 1/2 and 3/4, so that would have to be x being greater than 1/2 or x being less than 3/4. So to write that out, remember you can reverse that statement. So 1/2 is less than x, which is less than 3/4. We're going to use a less than here because this is an and, an intersection. Okay, let's talk about distance between points here. So in example 1, finding the length of a segment, find the length of BC. Well, BC is right here, and the difference there is 2, and so that is 2 spaces. We'll find the length of AC. Okay, for this one, you can't take the difference so much. Well, you can. I don't know. Let me think how I'd explain this. You're going to want to use the absolute value, basically. So the distance of negative 2 to 0 is 2 spaces, and then the distance from 0 to 3 is 3 spaces, and so the total of those is 5. So I almost said that you couldn't use the difference, but let me elaborate on that. So the difference from negative 2 to 3, difference is subtraction, right? So negative 2 minus 3. But it would be the absolute value of these, since distance is measured as a positive number. The absolute value of negative 2 minus 3, well, we get negative 5 when we calculate that, and the absolute value of negative 5 is 5. Okay, this is a word that's really important. We're going to use this pretty much all year. Oh, I'm going to say we're definitely going to use this all year. Congruent segments. Congruent segments are segments that have the same length. We can indicate congruent segments with tick marks. So this tick mark and that tick mark are stating that line segment PQ is congruent to line segment RS. So they have the same length. Okay, so if I write PQ equals RS, this means that the distance between the points P and Q is equal to the distance between the points R and S. But if I write line segment PQ is congruent to line segment RS, that this means that they are the same length. Segment PQ is congruent or the same length as segment RS. Okay, so this is our congruent symbol right here. It's really important. Let me highlight that for you guys. It's an equal sign with the tilde. Okay, segment addition postulate states that if you have two segments, such as line segment AB and line segment BC, then they add up to the whole segment AC. We're definitely going to want visuals with this, so let's see. G is between F and H using the segment addition postulate. So here's my segment. Oop. I don't like that. Okay, there's my line segment, and it's saying that G is between F and H. So let me call my endpoints F and H. And I'm just going to call this G, and it may not be drawn to scale because you don't know too much yet. You're just sketching first. So FG, they're saying, is 6, but FH, this total piece, is 11. And if that's the case, then find GH, the length of this segment, GH. Well, if you've used 6 of the 11 so far, how many is left for the length of GH? And that would be 5. Oops. So what we're saying with segment addition postulate here is that FG plus GH is equal to, we can make it very algebraic, is equal to FH. And let's plug in what we know. Well, FG is 6 plus, we don't know GH, is equal to FH, which is 11. And then we can solve for GH. To isolate that, we would subtract 6 from both sides, and GH equals 5. Okay, so this next one's the same idea with the algebraic statement. So we're saying that this 17 plus the 3x minus 5 is equal to the total amount, which is 5x plus 2. So I'm going to write that 17 plus 3x minus 5 equals 5x plus 2. Now I'm going to combine like terms. So 17 and minus 5, that's 12, plus 3x equals 5x plus 2. To keep my x positive, I'm going to subtract 3x from both sides here. It doesn't matter how you do this. I'm also going to subtract 2 to get the numbers to the other side. And so I end up with 10 equals 2x, divide both sides by 2, and x equals 5. All right, let's talk about midpoint now. So midpoint is what it sounds like. It's the middle point. It's halfway between 2 points. Another way to say this is that M bisects. If it bisects, think about bicycle, 2 wheels, right? So bisects cuts it into 2 congruent segments. Okay, the map shows the route for a race. You are at point X, 6,000 feet from the checkpoint C. 6,000 feet. The second checkpoint D is located at the midpoint between C and the end of the race y. And so that means that CD and DY are going to be congruent. So that keyword midpoint let us know that I have two congruent segments. And the total race is 3 miles. How far apart are the two checkpoints? So in terms of segment addition postulate now, I have that XC plus CD plus DY is going to be equal to the total XY. Okay, so let's fill in what I know. So I've got 6,000 feet plus CD, I don't know, I'm going to call it X, plus DY, which would be the same, so I'm also going to call that X, equals, and XY is 3 miles. Well, 3 miles doesn't help me because I need this in terms of feet. There are 5,280 feet in 1 mile. Okay, and I was given 3 miles. Just like in cross multiplying, we can cross simplify here. And so the miles cancel when I set up my rule this way, and I end up with 15,840 feet instead of 3 miles. Okay, and I can combine like terms here, but at the same time I'm also going to subtract 6,000 feet from each side. And so I end up with 2x is equal to 9,840. And then divide both sides by 2, and so x equals 4,290 feet. Okay, a segment bisector is any ray, segment, or line that intersects the segment at its midpoint. It divides the segment into 2 equal parts at its midpoint. So D is the midpoint of EF. Okay, so here's D is the midpoint of EF. And so I know that it's a segment bisector. It's splitting, it's making ED congruent to DF. And so now I'm going to plug in some information that I was provided. ED is 4x plus 6, and DF is 7x minus 9. And so since I know they're congruent, I can set them equal to each other. 4x plus 6 is equal to 7x minus 9. So this vocabulary is really important. If I didn't know what midpoint or bisector meant, I would not be able to do these problems. Okay, again, just to keep the x positive, I'm going to move my 4x this way, which means I would add 9 to both sides to get the numbers to the other side. So I end up with 15 equals 3x, divide both sides by 3, and 5 equals x. Okay, and since x is 5, I can now plug this into, it says to find, you got to be careful with the questions in geometry. You always want to go back and make sure you answer what's asked, because I could so easily stop at 5 equals x, and I'm incorrect. Because I need to answer what's asked. Find ED. Okay, well, ED was equal to 4x plus 6, and so I can replace that x with 5, and I end up with ED equals 26. Do the same thing with DF. Well, DF should be the same exact amount since those were congruent, but this is a really good way to check to make sure that I'm correct. So DF equals 7 times 5 minus 9, which equals 35 minus 9, and that's 26. If I did not get 26 here, then I definitely did something wrong. And so since EF, the last thing we have to find, is equal to ED plus DF, then I can simply add 26 and 26, or just 26 times 2, which is 52.